We have a balanced redox reaction, and we want to identify the oxidation half reaction. So we have to identify what's being oxidized. We do that by determining what's changing oxidation numbers. We can go through, look for things that look like they're changing. Obviously we're going to have a -1 for the chlorine monatomic ion. We have a +1 for the hydrogen, a +3 for the chromium, 0 for the element. Water is a +1 for hydrogen and -2 for the oxygen. And this action we'll assign as a -2 and use the summation rule to figure out what chromium is. So we got chromium +2 times 7 times the -2, and that'll add up to the -2 for the charge. So that's a 14, -14, move it over here, +14 minus 2 gives us a +12. We have 2 chromiums. We take the +12 divided by the 2, and we end up with a +6 for the chromium. So chromium is going from +6 to +3, a reduction in the oxidation number, so that's reduction. Chlorine is going from -1 to 0, an increase in the oxidation number, so that's oxidation. So that is the one that we want. So we have 6 chlorine going to 3 elemental chlorine. So we just brought down the elements. The coefficients is higher than we need. We don't need a 6 and 3. We have a common factor of 3 that we can divide out. So we can bring this down to a 2. Chloride goes to 1 chlorine. We have no other elements to balance, so all that we have left to balance is the charge. We have a 2 negative on the reactant side, 0 on the product side, so we have to add 2 electrons to get the negative charge back. So this would be our balanced oxidation half reaction.